I've always found this little exercise quite a bit of fun. Surds are irrational. We can't find an exact decimal value for a surd such as root 2. But strangely enough, we can find an exact position on a number line that represents the square root of 2, which is actually quite intriguing. You can't find an exact decimal value, yet you can find an exact location, which is quite odd. You might be wondering what this pair of compasses are doing here, and of course we're going to use that to answer this question. So what we're going to do is we're going to plot the square root of 2, square root of 3. If we've got time and the compasses can accommodate this, square root of 5, in fact, on a real number line. So let's have a look and see what we can do. All right. I've pre-prepared a number line already just to save a bit of time. So the first thing we're going to start off with is to plot the position of the square root of 2. So what I've done is I've marked out the positions of the integers 1, 2, 3, 4. Now, we know that the square root of 2, at least based on a calculator, square root of 2 is around 1.4. Okay, so 1.4 is probably around here. Okay, so just where I've got the pen there. So I might just put a little mark there, just a little tiny mark. So this is around 1.4. Okay, just on it, just small enough there that we can see. So we're going to estimate that that's where square root of 2 is going to land. So how are we going to do this? We're going to use Pythagoras Theorem. So Pythagoras Theorem states that if we're going to draw a right angle triangle first, and that the sum of the squares of the sides equals to the square of the hypotenuse. So what I'm going to do is I'm going to, in fact, I'll do this one in red actually. So just like that. Okay. Yep. All right. So I might just focus on that part there. Zoom in there. Right. So what I'm going to do is I'm going to form a right angle triangle. Okay. There's the right angle triangle there. That's 1 unit. Okay. So I've used 10 small squares here to give me the equivalent of basically 1 whole unit. So 10 squares along, 10 squares up. I'm going to say that's 1 unit long. Okay, 1 unit up. Okay, so 1 squared plus 1 squared. Okay, so Pythagoras Theorem states that, so 1 squared plus 1 squared gives you what? Okay, gives you 2. Okay, but we want the hypotenuse. Okay, so the hypotenuse, okay, is equal to the square root of 2. So that's just from Pythagoras Theorem. Right. So let's draw in the hypotenuse. Okay. Now, the hypotenuse can in fact be considered, or can be represented by the radius of a circle. So let's do that. So what I'm going to do is I'm going to get the compasses and I'm going to open it up to the length of the hypotenuse. Okay, so this really demands a little bit of finesse. Okay. So hopefully, yep, that's about right there. So let me just see if this is hopefully going to work. So let me just position the paper again. And yep. Okay, so what I'm going to do is I'm now going to swing the compasses just there. Yep. Okay, I'll zoom in again. And look where it's landed. Okay, just past the marking for 1.4. Okay, going back to the value of square root of 2 on the calculator, 1.414. Okay, and I think that's pretty close to 1.414. So that mark just there, all right, in fact represents the precise location of the square root of 2. I think that's pretty cool. We can't find an exact decimal for it, but yet we can find a location for it. And I just, yeah, that's one of the reasons why I love maths, right? It's certain things are just strange. You think, I can't work it out in one form, but in a geometrical form, I can work it out. And that's actually another reason why geometry is in fact such an important aspect of mathematics, because some things that are difficult with algebra or number can in fact be expressed in a shape. Okay. All right, the next one now is, or the next surd is the square root of 3. Okay, so square root of 3, I might just scribble this on another part of the diagram. If I draw okay, it's not the scale. Okay, so we want a hypotenuse of the square root of 3 because I'm going to do the same thing with the square root of 2. What short sides would I need? So in fact, if I had a square root of 2 on the bottom and I had a 1 here, would this form a Pythagorean triad? Well, let's see. So if I had square root of 2 all squared plus 1 squared, okay, that's equal to is that 2 plus 1, okay, and well, obviously that's equal to 3. So and 3 is just root 3 all squared. So I think we're happy with that. So root 2 on the bottom and 1 unit at the vertical short side there. Right, so let's do this again. Okay, so what I'm going to do just to make this a little bit more accurate, okay, hopefully what I tend to do is I tend to use 2 rulers to draw another perpendicular here. So what I'm going to do is, okay, so I'm just going to align the paper there. Actually, I'll do it this way, so I can zoom in here so you can see what I'm doing. Okay, yep. So I might just put a marking just there. Yep, so that's 1 unit up, square root of 2 along. So they're the 2 short sides. Take the pair of compasses, okay, so, oops, and we're going to open it up to, okay, so from 0 to, this will be equivalent of square root of 3 now. Okay, so again, try to get it as accurately as you can. Yep, I think that's good there. Okay. Might just make it a little bit smaller. Yep, I think I'm happy with that. Okay. So this mark here, this would represent, oops, that's the square root of 5, square root of 3. We'll get to the square root of 5 if we can. Sorry, this is the square root of 3 just there. Well, square root of 5 should be around here somewhere. Square root of 3, what's that, about 1.73? So let's check that. Yeah, 1.732. So does that land where it should have landed? So there's 1.4, 1.5, 1.6, 1.7, and that's about 1.73. So it's about right. Okay, so it does correlate with our estimate for square root of 3. So what about square root of 5? Okay, so square root of 5, we'll need how many units on the bottom? We'll need 2 units on the bottom, in fact. So, okay, if we use a different triangle, so I'm just going to recycle the same triangle here. Okay, if that was 2 units on the bottom, 1 unit up the top, 2 squared plus 1 squared, okay, that gives you 5. So the hypotenuse will be square root of 5. Okay, so let's do this. All right, so 2 along. Okay, so from 0 to 2, and then we're going to go 1 unit up to form a larger triangle. I'll do this one. This will be our final triangle. Hopefully this will work. Okay, lucky, it's actually on the grid lines themselves. So what I'm going to do this time is I'm going to form the larger triangle like that, and this will be a little bit. Yep. Here we go. Okay, there's another right angle triangle there. Yep. And so that's 1 unit up and 2 units across. So the hypotenuse of this larger triangle, okay, will form the radius of a circle, and we expect it to land a bit past 2. So square root of 5 is 2.24, or sorry, rounded, so to 2 decimal places, or around the 2.2 mark. So 2.2 should be around here. So this is 2.2. Okay, that marking there. So expect it to land a little bit past 2.2. So let's see if this works. Okay, well, yeah, close to 2.24. And okay, so hopefully I'll get this right. Yeah, that's about right. I'll just position the paper again. Yeah, so the compass here is opened up to the hypotenuse of this triangle. I might do the full arc this time so you can see how this works. And you can see here that it lands a bit past 2.2. It's around 2.24 or close to 2.25. So that's this mark here, okay, where I've placed that X. That there is the square root of 5. So now we've located 3 surds on a real number line. Okay, and yeah, hope you've had some fun watching this video.